Hello friends, good evening. So today we are going to see some new interview questions that might you face for data science interview. Okay, so let's start with the first question. The question is like, do you prefer Python or R for text analytics? What do you prefer Python or for text analytics? Take some time and try to give the answer of this question. The question is like, what do you prefer, Python or R for text analytics? Okay, so the answer of this question is, means it will depend on you. It will depend on your own opinion, but if you ask me, I will choose Python, because in a Python we have pandas. Okay, and the pandas library, in that we have better visualization graphs. With the help of that, we can find out more insights from our data, right? So that's why I will choose a Python. And also Python is typically faster for text analytics. Okay, so firstly, it is your preference, but most of the data scientists will prefer the Python. Okay, because Python is having a pandas library which has strongest data analytics tool. Okay, that's the reason we are going to choose a Python. Now the next question is, can you explain difference between the test set and a validation set? Okay, so the question is like, difference between test set and a validation set. Okay, so what is the difference between test set and validation set? So we are using the validation set. What is, firstly we understand what is the validation set. Validation set can be considered as the part of the training set. Okay, and test set is a different thing. Okay, that is a test data. Okay, means when we are dividing our data into train and test. Okay, 30% test we want, so 30% data is test data and other is the train data. So, and what is validation set? When we take some samples from that train data, that is the validation set. Okay, when we are using the validation set, it is used for parameter selection and avoiding overfitting while building a model. Okay, next difference is like, validation set we use for parameter selection and to avoid overfitting while building a model. Test set is used for testing or evaluating the performance of our training machine learning model, right? So there are two major difference between test set and validation set. Validation set is the part of a trained data set. Okay. And test set is the test data. Okay. Next difference is like validation set we use for parameter selection and avoiding overfitting. Test set we use for evaluating performance of our training machine learning model. Okay. Is that difference clear? Right. Okay. So we will go for our next question. What do you understand by linear regression and logistic regression? Question is like, what do you understand linear regression and logistic regression? Okay. Try to give some time, give it some time and try to answer this question in your way. What do you understand by linear regression and logistic regression? Okay. So the first technique is like, firstly, what is the difference? What is the definition we can go with that? Linear regression is form of statistical technique in which the source of some variable like output variable is predicted on the basis of the input variable, right? Linear regression means what? We have some input data. With the basis of that, we can predict our output, right? And that output could be continuous. Okay. And this is the, it is also known as the logit model. The linear regression model will be also known as the logit model. Logistic regression, it is a statistical technique for predicting binary outcome from a linear combination of a data, right? Both are using linear data, linear combination data, but in a linear regression, we are predicting the output in a continuous form, and in a logistic regression, we are predicting our outputs in a binary form, right? So this is the basic understanding of linear regression and logistic regression. Okay. Okay. Now, our next question is like, what is root cause analysis? In a simple term, try to give answer for this. What is root cause analysis? What do you understand if you see, if you listen root cause analysis? Try to answer this question. What is root cause analysis? Okay. So root cause analysis is the process of discovering the root causes of the problem. Okay. See, what is the name of this analysis? Root cause, right? So the meaning of that is like root cause analysis is the process of discovering the root cause of a problem. What is the root cause of that problem in order to identify appropriate solution for that problem, right? Root cause analysis assumes that it is more effective to systematically prevent and solve for underlying issue rather than just treating. Okay. So root cause analysis in simple terms, that what is the root of the problems, right? What is the root of this problem to identify the solution for that problem, right? Means if we know what is the issue, then we are able to implement a solution, right? That is the root cause analysis. The root cause analysis assumes that it is much more effective to systematically prevent and solve underlying issues rather than just treat it, right? Sometimes if we treat the issues, then also we're facing the errors, right? So it is better to solve those issues. That is the assumption of the root cause analysis. Okay. Is it clear for you? What is root cause analysis? If anyone asks you though. Okay. So we are go with our today's next question. What are the drawbacks of linear model? Question is like, what are the drawbacks of linear model? Okay. The drawback of linear model is like the assumptions of a linearity of error. It can't be used for count outcomes, binary outcomes. There are overfitting problem that it can't be solved. Okay. Means firstly, if you take the first drawback is like the assumption of linearity of the errors, right? We have assumptions for the linear model, like there is no multicollinearity issue in input data. There should be always linearity present in between input and output. Error should be randomly distributed. There is no connection between the errors, right? We have to always satisfy this condition. So these are the drawbacks. And other drawback is like it can't solve the problem of overfitting. We have so much assumptions in linear model, right? We have to always fulfill that assumptions in a way that is the drawback of that model, right? Because we have to always fulfill that assumptions, right? We have to follow like there is no relationship between the errors. Error should be randomly distributed, right? Error should be less. There is no multicollinearity issue. We want our data input and output. There is high correlation in between those, right? These are some drawbacks of multilinear model, sorry, the linear model. And one more is like, if you have binary outcome, there are overfitting issue that it can't solve for a binary outcome. Okay. Now, next question is like, what is resampling done? Or why is resampling done? Why resampling done? Take your time and try to think why we done the resampling. Okay. So resampling is a methodology we use to improve accuracy of our model, right? To solve an issue of overfitting, underfitting. For that reason, we are using resampling. Okay, to improve our model's accuracy and quantify the uncertainty of a population parameter, right? Resampling, it is the method that consists of drawing repeated samples from original data samples. What is resampling? Resampling is the method that consists of drawing repeated samples from the original data samples. The method of resampling is non-parametric method. Okay. There are four main types of resampling methods. There are some types of resampling like randomization, Monte Carlo, bootstrap. These are some types of resampling. Okay. So what do we understand? Resampling means we are taking repeated samples from our data. That is the resampling. Why we do that resampling? To avoid overfitting, underfitting, in a way that to increase accuracy of our model. For that reason, we are using resampling. And the types of resampling is like randomization, Monte Carlo, bootstrap. Okay, these are some types we are using for resampling. Is it clear? Okay. So the next question is like, what is regularization and what kind of problems does regularization solve? What is regularization and what kind of problems it solves? Think about it. What is regularization and why we are using regularization to solving which problem you are using regularization? Okay, so firstly, we understand what is the regularization. Regularization, it is a technique where we can add additional penalty term in the error function to increase accuracy of our model. Okay, what is the regularization? Regularization refers to what techniques that are used to collaborate machine learning models in order to minimize the adjusted loss function. Minimize adjusted loss function, that means minimize the error and prevent overfitting or underfitting by adding extra penalty, extra some of the extra element in that. Okay, we can fit our machine learning model appropriately on a given test set, hence reduce errors in it. Right, means when we are having issue of overfitting and underfitting, we will add some more information in that, some extra element in that, some additional element in that to solve that issue. Right, that is mean the regularization. That means we are retraining our model with the help of some additional information, to solve certain issues. Right, that is mean a regularization, and it is used to solve a underfitting and overfitting issues, like to increase the accuracy of our model. Is it clear now what is regularization and what kind of problem it is solving? Okay, now the next question is like, what is multipolarity and how can we overcome it? This is the most important question. Okay, if you are choosing regression, this question they are going to ask you, what is multipolarity and how can you overcome it? What is multipolarity and how you overcome? Okay, so tell me, what is multipolarity in your way and how to overcome it? So see, when we have a regression problem, for example, multiple linear regression, in that we have multicollinearity issue, right? In our assumptions, the MRR, multiple linear assumptions, what we said, there is no multicollinearity issue we want. Okay, so in multiple linear regression, we have one dependent variable and more than one independent variable, right? So we don't want any kind of relationship between our independent variable. What is mean independent variable? That means our input data, right? In multiple linear regression, we have more number of variables, more than two variables, right? Input variables. So in that input variable, we don't want any kind of relationship. Okay. If we have any kind of linearity, any kind of relationship in a way, in a independent variable, that is the issue of multicollinearity. Okay, how to overcome it? When we have multicollinearity issue, we have to check summary of our model. When we are checking summary of our model, in that we have p-value, right? So as we discussed yesterday, p-value greater than 0.05, that means there is some significance. There is, the value is okay. See, with the help of p-value, we can check is that independent variable is significant or not. Okay, if that p-value is less than 0.05, we will check it and we will finding like, okay, this is the variable, his p-value is less. That means this is not a significant variable. So we can remove that and solve a multicollinearity issue. But we can't take this step on only one scenario, because if we remove any of the variable, we are going to lose our data. For that, we want at least two proof, right? So the second way is like, we have VIF factor. Okay, in that what we check VIF value for each variable. The VIF value for those variable are going greater than 5, we are going to remove those variables, right? So we have two ways. Firstly, we can check a p-value from a summary of our data, and then VIF value. Okay, then we have influence plot as well. Okay, with the help of that also we can find out which of the input variable are influencing, and we are having the multicollinearity issue. If we remove that variable, we will solve that problem of multicollinearity. Is it okay now? Is it clear for you what is multicollinearity and how to overcome it? See, when we have relationship between our input variable, that means the multicollinearity, we will check with the help of a p-value. With the help of a p-value, when we take a summary of our model, we will check the p-value. If the p-value less than 0.05, that means the data is not significant. That column is not significant. So we have one proof to remove those columns. Second way is like, we have checking VIF values. If the VIF value for those columns are greater than 5, we are going to remove that. If you are asking me in visualization purpose, we have influence plot. Okay, in that we can see which of the value, which of the data is influencing, which of the column is influencing, right? And if we remove that data, yeah, we are able to solve the multicollinearity issue. Now, next question is, what is difference between squared error and absolute error? Even this question is much more important. What is difference between squared errors and absolute errors? So what is the difference between squared error and absolute errors? Okay. So the mean squared error, that means the squared error, okay? The mean squared error often estimator measures the average of squared of all errors. The mean square error of an estimator measures the average of square of the errors. Average of square of the errors, which means difference between the estimator and estimated. Right? Difference between estimator and estimated. What is the mean squared error? Square error means, sorry, the mean squared error. The mean squared error means estimators measures the average of square of the errors. Okay, average of squared errors. This is the mean of the squared error. Okay, and what is the mean absolute error? Mean absolute error is a quantity used to measure how close prediction to our outcomes, right? How close our future predictions to our outcomes. Okay, so do you understand? Squared error is the squared value of our errors. Okay, squared value of our errors means difference between estimator and estimated. And absolute error, that means it is measure how our predictors are close to the our outcomes, our actual outcomes. Now, is it clear? See, not much difference. Okay, mean squared error and mean absolute error. That means the mean of the squared error and mean of the absolute error. Okay, so the squared error is just a squared of value of error. Whatever the value of error we are having, square of that. Okay, and absolute error, that means it is taking what is how close our prediction, our future predictions, whatever our predictors to our actual outcome, whatever we having now, right? The difference between those. Okay. Now next one is how our confidence interval constructed and how will you interpret them? Okay, I will write down the question and then you will understand how our confidence interval constructed and how will you interpret them. Okay, this is the question. How are confidence interval constructed and how will you interpret them? Okay, so the confidence interval displays the probability of the parameter will fall between the pair of value around the mean. Okay, confidence interval is nothing but it is showing you the range of value that in that our future mean will lies. Okay, our future value will be lies. Okay, means when we are performing any event, like when we are calculating confidence interval, we get two values. One is minimum, one is maximum. That is the range of the values. Okay, and in between that range, our future parameter will lie around the mean. Okay, around the mean of those values, right? Confidence interval measures the degree of uncertainty or certainty in a sampling method. Okay, what it is measuring? It is measuring degree of certainty or uncertainty. They are most often constructed using confidence interval level like 95% or 99%. Okay, so we take example of 95%. A 95% confidence interval of a mean is the range of an upper and lower number calculated from a sample because the true population mean is unknown, right? The range describes the possible value of that future mean could be lie. Understood? Means when we are calculating 95th percentage confidence interval, it will give us two value, minimum value and maximum value. After calculating that, we can get, we sometimes we are not able to calculate the population mean because of the size, but this is the range the confidence interval is giving us. In that range, the value of our future population mean could be lie. Okay, is it understood? Means a confidence interval displays the probability of the parameter that will fall between the two pairs of value. It will giving us the probability of the event that will occur in this range. Okay, and if the range, sometimes we will take confidence interval like 95th confidence interval, 99% confidence interval. If we take 95% confidence interval, that means we are calculating our upper and lower limit. Lower limit is like 5%, upper limit is like 95%. In between that range, our future population mean will lie. Okay, could be like, could be in between that range or future population mean, right? Is it clear what, how are the confidence interval and how we interpret them? Okay. Now the next question is like, how can you avoid or overcome overfitting? How can you overcome overfitting? Try to answer this question. How can you overcome overfitting? Okay. Firstly, we understand what is overfitting. Overfitting means your model is only relevant for that set of a data. Okay. And irrelevant for another data. That means if you are running your model on actual data, so it is giving you best accuracy. But if you take a new data set for that same model, it is not giving you that much accuracy. That is mean overfitting. Okay, means when you are giving a trained data set, sorry, test data set, and running a model on that test data, it is giving the best accuracy. But when you are adding your trained data set or any future data for that same model, it is not giving you the accuracy. Okay, that much accuracy, that is the value of error is high. That means the overfitting. Okay, there are some techniques to prevent overfitting, like cross validation, feature selection, L1, L2 regularization, remove layers of your model, uh, how many numbers of unit you can decide for your model, right? These are some ways to overcome the overfitting models. See, what these techniques are going to do, it will reduce the complexity of your model. If you reduce complexity of your model, the overfitting issue is solved. So the regularization technique is they doing same regularization, adding penalty term there for penalty for higher terms in a model, and thus it is control the complexity of the model. If we add regularization in our model, it will try to minimize the complexity and minimizing the errors. Okay, so in this way we can solve overfitting. There is not only a regularization technique to solve overfitting, like there are some more techniques like in a regularization, like cross validation, feature selection, L1 L2 regularization, remove layers of your model, right? Then you can overcome the problem of overfitting. You can solve that problem. Okay, for if you are doing some, if you are giving some of the hyperparameter, right, and those are more suitable for your test data, it is actually giving you the best accuracy for that. That means your model is just only going to give relevant answer, relevant prediction for only that data. But for future data, it is not giving. You have to solve that problem. That is the overfitting problem. To solve that problem, you are using regularization techniques or cross validation technique, or we are going to do feature selection. Okay. Yeah. So in a way, you can solve a hyperparameter. You can solve a overfitting issues with the help of this simple techniques. Okay. One suggestion is like, don't make your model more complex. Okay. If you make your model more complex, more hyperparameter, if you add there, then it will show you overfitting issue. If you are avoiding that before doing a model, you will not get overfitting issues in a way. But if you get, there are the techniques to solve. These are the techniques to solve. Okay. Okay. Now I am asking you one important question. This question, even I have seen in my interview sometimes, like, it is better to have too many false negatives or too many false positives. Which you're preferring? Is it better to have too many false negative or too many false positive? Okay. Try to give answer of this question. Which you are going to prefer? Too many false negative rates or too many false positive rates? Means you're okay with that. Okay. It will depend. It will depend on the domain, on what domain's problem you're going to solve. Okay. It will depend on that, to which you are going to give more value, for false negative or false positive. Okay. But since false negative result pose a greater risk, most of the testing application are set up to minimize the occurrence of the false negative result. Okay. This means the false positive results are more likely occur and therefore more often found as a topic on a discussion. Okay. Means we can accept false positive more than false negative in some certain condition, but it will totally depend on what domains, not what domains problem you are going to solve. Okay. We can think with the help of some examples. See, for false negative, we can think a COVID example. If anyone goes and do the COVID test, if he get a false negative result, right, what will going to happen? If he get a false negative result and complication will increase, that person might chance to goes to die, right? So we can't afford this. In this case, we can give more preference to false negative result. We want to minimize the false negative result, right? This is the scenario for false negative. But if we check another scenario, for example, in a case for false positive rates, okay, in a case, uh, in a court case, there is one person and some of the and some case is going on, and he will be, as after our model, he will specify it as a, he is not innocent. Okay. He is not innocent. The judge is telling like he is not innocent. he have to get some punishment and all, right? But that is not a positive thing. That is the false positive result. That is the false, on the basis of that false positive, on that false positive evidence, it is giving him a punishment, right? But if that person is innocent and he get the result, he get any kind of punishment like 2 years or 3 years or 5 years of punishment, he is actually innocent person and he is going to live his life in a jail. That is not a good thing. See, here false negative thing is not that much matter. See, if any of the part, if any of the criminal, he's a criminal, but he can be finding as okay, this is innocent person. He could be, judge will be give result like this is the innocent person. This is not a criminal, but actually he is criminal. So does it impact? No, not that much. Okay, but if any of the innocent person, judge will give like no, this is the not innocent person, he is a criminal, he have to go to the jail and he have to full he will give him some punishment. So yeah, he is going to lose some of his important year of his life in a jail, right? He can't afford that. In this scenario, we can give much more importance to false positive rates, right? So it is totally depend on the scenario. It is totally depend on the domain, for which domain's problem you are going to solve. Okay, it will depend on that, to whom you are going to give a more value, false negative or a false positive. Is it clear? See, for false negative, we can see the cancer patients as well. The example of cancer patients. If he is not, if we take example of those, if the person is having the cancer and in the test it is showing no, he is not having a cancer, right? So that person may be relaxed, he will not going to do another test, and after some days he will finding it out like this is the last stage of cancer. That time we haven't finding out, so it will cost more, right? In that scenario, false negative is much more important to identify, to remove those things, to remove false negative states, right? Yeah, so it will totally, if anyone asks you, it will totally depend on the domain. Tell them like it will depend on the domains. If client come with me, I will firstly identify which domain, which problem, whatever problem he is having. On that basis, I am going to give an importance on false negative or false positive. Is it clear now? Okay, so yeah, that's it for today, friends. Thank you so much. We will connect tomorrow again on the same time to discuss further questions, for the new questions for a data science interview. Okay, till then, bye bye. Thank you.